Hello, my name is Raelene Gonzales. I study at the University of San Diego, and today I am discussing smart cities, road and street maintenance. This is a project for design of smart cities done by Group 4 with David Espley, Eduardo Pizarro, Raelene Gonzales, and Taciane Conrad. We'll be discussing our plan for AI, predictive maintenance, and sustainable infrastructure in cities near you. An introduction to this topic, we have AI and machine learning, IoT sensors, data from autonomous vehicles, and sustainable infrastructure like smart pavements. For example, I was in a near crash the other day, and for an engineer, this is quite scary for me. Researching such topics that hit so close to home are important for us, the minds of today, to discover how we should go about to improve the technological, social, economic, and more issues that we face. The proactive pothole detection was one of our key findings. There's an impact study on the city of Memphis and how pothole detection was effective at preventing accidents and mapping out cities. Some of the key findings that we learned are all listed here. The second one being predictive maintenance using machine learning and weather and traffic data. For example, public data that is scientifically accurate, such as the AIRS data program. The data is accessed publicly. It's provided by JPL NASA, Jet Propulsion Laboratory in Pasadena, California. Using such government standard and satellite trafficked data that is publicly accessed and 100% accurate from as far as we can tell from our best scientific technology is important. Using the open source AIRS API systems and anything else that really is relevant to how our machines will work will really predict what cars should be doing and how to traffic them through the cities. Machine learning is something as engineers that we are extremely adept at creating. Machine learning can be something that our engineer team spends quite a lot of time on because we are the only ones that really know how to train the data if it's our personal data that we've gathered and assured that is safe for the public. Additionally, real-time accident damage and assessment and mitigation is really vital into getting cars off the roads once the accident happens. But real mitigation is also important. So not only are we assessing the damage and creating a plan for our smart city, but the mitigation will be assured by rubber-coated roads. So we have research from Arizona State University by Professor Camille Kalash, and we will be studying exactly with the NIOP research and development team on real estate and other related practices that colleges, especially the Arizona State University developers on bridges and pavement are utilizing. We're making sure that all this information is accurate. So currently there are such things called rubber roads. So basically the rubber is under the pavement as well as you can add sensors, do pretty much anything. So I'll get to the sensors in a moment. However, also rubber from reused tires, recyclables can be ground into particles, and these particles can be fit in the road to mitigate the damage. We're also considering things like bumpers on the side of freeways just anything that really is safe and mitigates damage, as well as considering autonomous vehicles. So that's would be another major key finding for enhanced road monitoring. So if you look at the fourth key finding, we have AV, autonomous vehicles, data integration for in-hand road monitoring. So this we can put sensors in the road with the rubberized road from the findings of the colleges, and we can also have electric vehicles or perhaps just autonomous vehicles, but autonomous vehicles are electric, and we will be able to actually charge the roads, charge the vehicles from the roads. So there'll be electric sensors, and this would only be in the part of town that is very dense, you know. So we'll talk about the SOMO partnership. There is a company that already has studied how the impact of the on social integration will be for autonomous vehicles, and they also partnered with Here Mobile. So that's SOMO and SOMO and Here like HERE. And they've already had 4.1, no, 1.4 million cars that have been integrated in over 350 cities globally. They have an app that not only connects to public transportation, private vehicles, but also bikes and taxis, and they're all studying how the impact of the cities with these different kinds of methods of transportation are affecting the cities, and also the Here mobile is all autonomous vehicles that use SOMO. So we're really seeing a global change, and the business is still running really well. And I'm going to go back for a second and talk about the mitigation. Rubber is sourced well, and the damage can also be reported by SOMO. So we've got a social network that can be it's it's open source, so it will be able to easily integrate with any services that we create. So any of the pothole detection, the machine learning with the weather and traffic data, the real-time accident damage assessment and mitigation can all be integrated with these autonomous vehicles that are running on enhanced road monitoring software. And all this can be provided by SOMO in here, and also the AIR's weather and traffic data. And also we can just create our own integrations. We have that capability as a team. And lastly, I'll get to smart pavement for energy harvesting and condition reporting. This smart pavement takes the rubber technology that we have for damage assessment and mitigation, and it really combines it into creating excess energy. So with the roads being so heavily trafficked, smart pavement is really an integration technology. And so many new technologies are using energy harvesting and connecting this energy harvesting to solar panels that are installed across the globe. We call this anti-fossil fuel technology. We're also doing environmental studies. So again, let's take a look at this chart. So this is kind of like a process of proactive insight time-sensitive prevention, health monitoring, focus detection, and interruption of failure. This is how we will prevent damage and mitigate damage, and also connect our society with the correct methods of transportation that really give people the option to do what they're still doing. So people can take their bikes, they can drive the cars, they can use the autonomous vehicles, they can use public transportation. But all of this will be backed by research and is backed by research. So no one will be questioning anything of the process and they'll feel completely safe the whole time because the user experience does apply to smart cities as well. And let's go more into the impact analysis. This is the four categories that we've broken it up: technological, social, economic, and environmental. We already discussed technological. We have improved monitoring and a faster response. So something happens on the road, someone's in trouble, or a good things happen. So we've got more traffic in this area. We've got events in this area. We have people wanting to socialize or meet up at certain locations. We've got job traffic. We've got suburban residential traffic. Anything like that can be managed by technological advances, and especially the AI training that we plan on coordinating with the rest of the team, such as the Soma app or the Here autonomous vehicles. It's very exciting. And the economic impact, this is reducing cost and generating energy, reduce cost and energy generation. I think this is a plus for our society. And if we're using recycled rubber and we're using recycled energy and we're gaining on electricity to power our vehicles or whatever sources that we may choose to use, it really just is a step forward for transportation. And we'll be able to use this saved money on something that matters for our economy. Social wise, safer roads and fewer accidents. And not to mention more positive communication between our transportation system. Environmental, we've got lower emissions and greener infrastructure. Not to mention saving a lot on just using harnessed rubber and reused rubber for our smart pavement roads, reused sensors, sensors that last, just being mindful about our emissions and creating green. We can even have spider plants, stuff like that, creating more oxygen. And, this is also detailed in the City of Memphis impact study. So, I mean, that city's already on board with improving their infrastructure from potholes to, plans they have ahead. So we can always start there and use that as an example city. But, we're willing to pick up any city. Los Angeles is somewhere that I'm home from, and I'd really like to see the impact that it has on all of our cities. And that would be, US to global. California is where we reside as a university, but statewide, other states, other countries. So let's move on to forecasting. With short term, we've got the AI pothole detection going. We've got autonomous vehicle data on integration pilots. And this is all about integrating our machine learning with our weather data, with traffic data, with SOMO, smart cities traffic communication, as well as the actual autonomous vehicles that can be from here. We can also use Waymo. There are different technologies and a lot of people that are willing to use their technologies for good. And then in the long-term run, we have scaled smart pavement deployment. Real estate infrastructure is going to be the major thing. So we've got the NI in a IOP research with different colleges, such as Arizona State University, but really scaling this out and having sample smart cities such as the grids um, that are all technology. So we can use some current SOMO software that has example uh, cities. So you can map out Los Angeles and you can see what happens in real time when people show up. And then, of course, using this on smaller cities, such as, outskirts of a city, and then moving inwards. So, city of Memphis, and then scaling that to larger cities eventually, such as Los Angeles, California, and then, testing across different cities and different states and global, and just getting as much data as we can while we build the actual smart green infrastructure. And then we have citywide predictive maintenance systems. So this is really just making sure that everyone's on board with the same integration and the same software, the same hardware, and making sure that the communication really works. And of course, everything goes back to our original team, and we'll have a lot more people on this, but mainly just us. And yes, so we're giving a lot of time for this project, 3 to 5 years. Um, and then, of course, in the long term, this is something we plan on sticking to as a smart city designer. Conclusively, our smart road maintenance enhances efficiency and safety. Our AIs and our AVs, autonomous vehicles, enable real-time insights. And of course, the smart pavement promotes sustainability in all terms. And then our collaboration and phased implementation are key. And that's our proudest moment, is our collaboration, is our phased implementation. And thank you so much for allowing us to present our idea to you. Group 4 thanks you. Thank you.